So, as we kind of go through multivariate data analysis, part of that is displaying multivariate data, okay? And there are, I guess there are a few parts to displaying data, okay? One is for exploration, okay? So one, maybe you're not sure what the data looks like to begin with, and so creating displays can help you kind of understand the underlying structure in the data, okay? So that's part of it. There's an exploratory section in displaying data. Okay, and then there's kind of a creating displays for communication, all right? And so usually after you've done some exploration and you have an idea of some of the structure that you see inside the data, maybe you want to communicate this to an audience, all right? And so when it comes to that part, there's two key questions that you should always be asking yourself whenever you make a graph, okay? And those two key questions are, what is the point I'm trying to say or trying to make with this graph? Okay, what is the purpose that I'm trying to illustrate? You should always be able to answer that clearly, because that's going to influence what your display should look like. And then the second question is, what is the simplest way I can illustrate this? All right, and so there are over many years of statistical analysis and whatnot. We've developed other types of displays, and our textbook mentions a few of these. We've got these glyph plots and star plots and all of these different things. And they serve their purpose, and we'll talk about some of them later on. But a lot of times you want to just use the simplest display that requires the least amount of explanation, that the most amount of viewers can interpret readily. Okay, and so for a lot of that, a scatter plot can do the trick. Okay, so it's a very versatile graph, and the great advantage of using scatter plot is that most of the people are going to be familiar with reading a scatter plot. Okay, and you can use it to display lots of stuff. The great disadvantage is that it's intended really for just displaying two variables at a time. You might be able to extend it to display a third variable or a fourth variable, possibly even a fifth variable, but really anything beyond that, it's not going to be very useful. And once you get past three variables, you lose a lot of the simplicity or elegance of the scatter plot. But we'll take a look at using scatter plots, kind of both for this exploratory aspect and also kind of this displaying information aspect. And I'm going to do it with Ggplot 2, which is a useful package, but you have other options too. Yes. This part's too small here. Yeah, this is just me kind of pretty. Okay, sure. Let's see. Appearance. Is that any better? Okay. Sure. All right, so yeah, this is just kind of, I I pretty much summed up what this says, or this sums up what I was talking about. So we'll take a, so within R, load up library ggplot2, okay, and we'll take a look at the diamonds data set. Okay, so before we do that, you can call up data diamonds, okay, and then you can ask to view diamonds, and this is what it looks like. And you can also ask for help on diamonds, and this is just one data set that came as part of Ggplot2, so that's why I'm using it, but it's lots of other data sets we can use. And so this is, it says the prices of 50,000 round cut diamonds, okay, so almost 54,000 diamonds. So if you guys I guess just some introductory information. Some of you might be considering getting married one day or getting engaged, and for some of you that might mean either purchasing a diamond or receiving a diamond, and it's this piece of carbon, but but like all like everything in this world, as a human race, we have assigned great value to this thing, right? Just like gold, gold in of itself is not like, it doesn't do a whole lot, but it's shiny and it's pretty and there's not a lot of it, and so as a human race we've said this is valuable, okay? It's not like uranium where there's a whole lot of latent energy stored up in it, even though it might give you cancer. So we've got diamonds, and and because we've assigned value to it, it causes all sorts of conflict. Just like whatever, it can be the most meaningless thing, but as soon as you assign value to it, people start fighting each other because of the value. But anyway, there are these aspects of a diamond, and they're known as the C's. And there's the carat, which is basically how we measure the size of a diamond. Okay, so generally bigger is better. Okay, the cut. So when you go into the mine or whatever and you pull out a raw diamond, it's not pretty. Okay, a professional or a robot or somebody has to cut it using kind of these, like, what? Well, yeah, you gotta use other diamonds, or just, well, it's kind of like glass, so you can just shatter things too. Yeah, so diamonds are hard, but they also shatter, so don't like take a hammer and test out the hardness of diamond. It's like, glass is hard, but it'll break if you throw a rock at it. So it can happen to a diamond too. So anyway, the cut, so a person has to cut it, and then I guess they look at this diamond very carefully, and if there's little particles in there, that reduces the value of the diamond. And if the diamond in itself has some color and it's supposed to be clear, or colorless, or maybe it has a slight yellow tint to it, they give it these letters to say it's not that great or whatever. Okay, and then to kind of measure how big the diamond is, you can also measure it in millimeters and whatnot. Okay, and yeah, that's the diamond. Okay, and so here are all of these. We got 54,000 of these diamonds, and this one is 0.23 carat. The cut is ideal. Okay, we have it's a factor, and it's in this order. Fair is the least best of the cut, and ideal is the best cut. Okay, color goes from D being the best to J being the worst. And then you know, this is how much you'd have to pay for the diamond, okay? $326. That's the cheapest diamond you can get for a 0.23 carat thing with Si2, which is apparently not very good clarity. It's got specks of stuff in there, okay? So, you know, we might just say, well, okay, well, let's take a look, all right? And so, you know, the basic plot function in R is plot, and you just do kind of an X versus a Y, and so we can do carat. I have to do diamonds, $carat on our X-axis versus diamonds, $price, okay? And it looks like this, okay? And we got all these dots on the screen. We can use Ggplot, and I like that. And so I type in Ggplot, and the way Ggplot works is first you have to list off the data set that you're using, okay? And then you give it an aesthetic mapping, okay? And that's used with the command AES, and you basically have to say, okay, the aesthetic mapping is that I want X to be the carat and Y to be the price, okay? And that's that. And if you hit enter here, nothing's going to display, okay? You have to give it a geometry, okay? And so with Ggplot, you give it kind of an aesthetic mapping of how the data should be mapped to aesthetic attributes, and then you give it basically a layer on top of that that says this is what I want to be displayed. And so in this case, because we're doing a scatter plot, the geometry that we're adding is point geometry. So you have to say, so you basically finish off your Ggplot command, and then you say plus, and then you do geom underscore point, okay? And then you have to put in the parentheses to say that that's what you're calling. And then you hit enter, and it's going to look pretty much exactly like the graph that we have here, except it uses kind of Ggplot's default kind of coloring and dots. And this is what it looks like, okay? And so in our case, we've got this is just kind of an early exploratory analysis of carat versus price, and we see kind of what we expect, which is, you know, as carats go up, as the diamond gets bigger, the price of the diamond goes up. Okay, that seems to be the overall trend. No surprise there. But you know, we also have so many of these dots that it kind of gets hard to see. So you can handle some of this with Ggplot by reducing the opacity of each dot, okay? And this is by setting the alpha attribute. So you say alpha, and you can give everything a 10% opacity, okay? And so I'm doing the exact same thing, and so you know, we kind of see, all right, it looks pretty much the same, but you know, now it's a little bit shaded. And so we can see kind of, you know, the great concentration of where diamonds are appearing. And you know, it's no surprise that just because of the way we've artificially set up how you know, the sizes of these things, people like nice whole numbers, right? So you get diamonds of exactly 1 carat quite a bit, diamonds of 1.5 carat quite a bit, 2 carats, you know, you're getting kind of these bands at these locations, and you know, even bands at exactly 0.5 carat, and this looks like, you know, 0.7 or 0.75 carats, and this, I don't know what this is, 0.9 or something, you know. We're kind of seeing these bands form just because people like to, you know, nobody wants to say, honey, I got you a 0.87 carat thing. They're just, why didn't you get me the 1 carat diamond, you know? We're silly like that as people, you know? So you know, so we sort of see this, you know, this kind of structure, and you know, you can reduce the alpha to, you know, 1% alpha, 0.01, and basically you still see this same sort of thing, and basically, you know, where there were dots out here, they're practically invisible, but you see this, and you also kind of see this funny line right here. What's this horizontal line that we're seeing here? This is price, right? So we're seeing just kind of this weird thing where like people don't want to price a diamond a certain amount. It's kind of hard to tell, but it looks like, what is that, $1,500 or something? I don't know. For whatever reason, huh? 2,500? I think this horizontal line right here is 2,500. So it's a little bit less than that, but for whatever reason, it's like, you know, you set up, I don't know. People, for whatever reason, people aren't pricing diamonds at this value. Maybe there's a glitch in the system. I don't know. But there definitely seems to be something there. Okay, so that's so maybe I'll leave the alpha there, and we can explore some of the kind of the other things. We can look at you know, what if I look at these attributes x and y, and so if we go back to the help, kind of like what did these things, this is the length of the diamond and the width of the diamond and the depth. So I'm not, we'll look at the length and width of diamonds, okay? And, okay. And so what we're seeing is this very, very straight line pattern, okay? Maybe I'll get rid of this alpha attribute. Okay, and so you know, almost all of our diamonds lie on this very, very straight line. We see a few outliers, and this seems rather odd. But if we read it, it says these are 50,000 round cut diamonds, and if I were to go onto Google and ask diamond. Well, we have these other attributes, table and depth, but so this is, you know, diamonds are big business, so let's see, length and width. Okay. Well, I think I'm trying to figure out where this, I have no idea what this is talking about. But basically, if you're thinking of cutting a circle, right? Somebody's got to cut this circle. You want your length and your width to be about the same. Otherwise, it's not a very good circle. Okay? So you're going to see this very, you know, it makes sense that you see this very straight line relationship, because as the width increases, you're expecting the length to increase if you're talking about the dimensions of a circle. Whereas if we if I changed it to z, the depth, you get a little bit more scatter here, okay? And that's because, you know, kind of in the ideal diamond shape, it shows you like this is the ratio that the depth is supposed to have, but you could kind of have these I guess different depth diamonds, right? So you can have the, if I were to tell you to draw a diamond, you know, some of you will make the diamond a little bit more pointy down here, and you know, less. You'll have a shallow versus more deep, and apparently the ideal ratio is 62.5% or some. Who knows? Something. Okay. So anyway, you can kind of explore the different relationships here. Some of these things, cut, color, and clarity, these are factors. Okay, so you know, if I just said, give me the first of diamonds $ cut, okay, it'll say, okay, the first few diamonds that we look at, you know, it's ideal, premium, good, very good. And it tells you, oh, this is a factor. We've got, you know, different levels here, okay? And so if we tried to plot these, so if I map things onto cut, it does this, but then this is not a very useful display, okay? Because, you know, we're getting this kind of this, we're plotting things as a factor, okay? And so, you know, when you're plotting a factor, you know, it's probably better to turn it into like a box plot or something like that, okay? So when you want to display something with these things, a lot of times it's better to explore kind of the relationship between two numeric variables and then map the factor attribute onto a third dimension, maybe the size of the point or the color of the point. Okay, so I'm going to go back to we're going to go back to plotting the carat versus the price. Okay, so that we're going to go back to this display, and then we can look at you know, maybe the clarity of the diamonds, or the cut of the diamonds, or the color, and we can map that to another attribute. Okay, so for example, rather than just having all of these plot dots black, I can say the color. Okay, and because this is Ggplot 2, which was made by Hadley Wickham, who's from New Zealand, they spell color with a U. And I'm going to map that to the attribute color, okay? All right, and we get this this rather, it's a little bit painful to look at in the eyes just because it's so much stuff here, okay? And the default mapping, okay, it treats it as a factor, and so D is the best color and J is the worst color, and it kind of works through the rainbow. If you can see these dots over here on the right, and you know, what do we see? We see a bit of a pattern in the dots themselves. Okay, we see, you know, for the same color, I mean same sized carat, okay, so if we're looking kind of along this column of 1 carat diamonds, what we see is that the crappy colors, J, is down here at the bottom, okay, and as we move up in price, you know, now we're getting, you know, the red, the D, which is like the best color, so the highest priced diamonds are up here, and they're all kind of red, and we kind of see the rainbow gradient going down. So which is no surprise, right? Like if the color, you know, D is supposed to be the best, those should be the highest priced, and we kind of see that pattern. It's you know, if you were to take if I take my glasses off and look at this in this blurry fashion, you know, you can kind of see a little bit of a rainbow pattern in the thing there. Okay. Now you might not like the default coloring of these dots, and you might even argue this is too much in one thing. So you can do a few things, right? We can use our alpha trick to reduce the opacity, and this helps a little bit. Maybe, okay, and maybe this just overemphasizes that that most of our things are kind of in this green, in the middle-ish ground color range, okay. Another option, okay, maybe you don't like this this coloring, you can choose what's called the scale color brewer, okay, and you can also, you know, more details if you just type in ggplot. Scale color brewer or whatever. They kind of give you some palettes that that you can work with. So if I just add this option, scale color brewer here, so I'm going to use the exact same thing. So I'm plotting ggplot with the diamonds. My aesthetic mapping is that the carats are, the size of the diamond is X, the price is Y. We're mapping the color of the diamond to the color of the data point, and we're going to add scale color brewer. And so this takes it rather from a rainbow to here. It's using this blue kind of monochromatic scheme, and so in this case D is the best, and it shows up as white, and you get this gradient from white or very light blue to dark blue. Okay, and we see this you know, the same pattern where the lowest rated diamonds, those that show up in the darkest blue here, are at the bottom, and at the top of the curve we have the lighter colored dots. Okay. Okay, and so all of these things, and you can change this if you don't like the color blue. You can say palette is equal to you know, oranges. Oops, did I not type that in correct? I spelled palette wrong. Oh, yeah, that'll do it. Okay, so whatever. You can mess around with this. They have different sets, and I guess if you like orange brown colors, this is what you get. You can modify the size of your dots, which, you know, when you got 50,000, maybe this probably is not the greatest move, but I'm going to set size equal to 7, and we're going to have these giant circles here, where they're almost, you know, kind of getting in. Well, they clearly are getting in each other's way, but you know, this might actually come in handy if we use the alpha equal to 0.01, and we make everything nice and light, and we'll take a look. We'll see if my computer can handle it, and now it looks like we just have poor vision here, but okay, but you know, and we still see kind of the structure of diamonds being cut at certain sizes. All right, so you know, you got to ask yourself, well, what is it that I'm trying to communicate here? Okay, oh, I'm sorry, and there are other attributes that we can mess around with. So not just the color of the data point, you can also change the symbol that we're using. So the default is kind of just a round dot. But if you want to change the shapes, so let's say, and this is going to look terrible if I do it, but we'll go for it anyway. So rather than changing, mapping the color, we'll map the shape of the dot being plotted to, we'll say the cut of the diamond, okay? So this thing is useless to view, but over here it says, you know, fair is the circle, and good is this triangle. Very good is a square. Premium is a little cross, and ideal is a little square with an X in it. Okay. Now, and all you see is just a bunch of garbage on this thing, and so clearly this is not a very useful graph. I mean, it's not a pretty one. It might. I don't think any of us can really look at this and pick out any patterns here regarding the cut of the diamond. Yes? So
all these added arguments that we're doing for these plots are only for Ggplot. We can't use these arguments for like normal scatters, correct?
Okay, so in normal scatter plots you can do this, but it requires a lot more work to make it happen. Okay, so Ggplot 2, it has these nice, just kind of this nice, what they call a grammar, where you say, okay, I want to map this aesthetic attribute of the graph that I'm creating. And so right now I'm just talking about scatter plots. You know, if we were to make other types of plots, you know, the aesthetics of those graphs would be different. But today we're focusing just on scatter plots. And so you think of, you know, what are the aesthetic attributes of a scatter plot, okay? You've got your x-axis, you got your y-axis, and then there's attributes of the dot themselves, okay? And so we've looked at altering the color of the dot, so we can map the color of the dot to or I should say, we can map a certain variable to the color of the dot. We can map another variable to the shape of the dot being plotted. We can map another variable to the size of the dot being plotted, okay? And so all of these things, these are different attributes, and so in a sense we can, you know, maybe map 5 attributes onto this map, onto our scatter plot, and we might still be able to pick out some pattern or recognize some things in the plot. And so, you know, maybe you know, with 50 some thousand diamonds, this might just be far too many, okay? And so maybe I can reduce this, and so I'm going to use a dplyr to kind of just filter out some of our data, okay? And so I'm going to first I'm going to just chop it to just diamonds that are 1 carat in size. Okay, so to do this, so if you're not familiar with dplyr, it's an excellent package, and it's useful for kind of manipulating or filtering out your data with a few simple commands. So in this case, I'm going to load up library dplyr. And I'm going to take my data set diamonds, all right, and I'm going to use this symbol, which you can get by typing in Control-Shift-M or maybe Command-Shift-M on your keyboard. It's basically % greater than %, okay? And what this does is it just feeds the data set diamonds into the next command that we want, okay? So in this case, I'm going to apply a filter. Here, I'll get rid of that. And the filter is, I want just the carat size of the diamond to be less than 1, okay? And so this won't even take the, if it's exactly 1 carat, it's not going to show up here, okay? I mean, I can do that. I can do less than or equal to. But, you know, just for simplicity, we can do this. All right, and I'm going to just I'm going to save this as F diamonds. And so this is our standard, you know, store the results into this object here. So it's going to store the results of filtering into here, okay? And so when I do that, we see, oh, you know what? There's a lot of diamonds that are less than 1 carat in size. There's just still like 35,000. But we can try plotting these, okay? And I'm just going to run ggplot on F diamonds here, the filtered diamonds, okay? And when we look at it, okay, we see all of this, which is, it's still just too many, right? Yeah, and there's kind of this weird thing where people don't want to price the diamond exactly at this, and I still have no idea what price this is. This is like 1,300? I don't know. Maybe that's like a bad luck number and people don't want to price their diamond to be 1,000. I don't know. People are weird. It's the truest thing I can tell you in this class. All right, and so this maybe this is still too much. So, you know, we can filter this even more. We can just say sample underscore n and just say, you know, pick just 1,000 of these rows, okay? Okay, and so now we've randomly picked 1,000 of the rows, and these are the diamonds that we have. Okay, and you can play around with this. Maybe you want more than 1,000. You can get 5,000, and you get this. Okay, alpha equal to 0.1, and this will also speed up your graphs just because you only have 5,000 points or 1,000 points to graph rather than 50,000, right? Okay, so you know, just messing around, we can plot the shape of the diamond to these things, and it's still kind of hard to see. So maybe we want to increase the size of our geometry to have larger dots, and then we get this problem. And so, you know, the actual symbol that you're using, maybe can mess around with what you want to do. And so if you want to specify which dots you want to use, okay, so it's probably not ideal to have these colored in dots, right? Fair, good, and very good. They're these solid colors, and they really obscure each other when they're stacked very close to each other. So, you know, maybe you can manually specify which shapes you want, okay? And so this is using the exact same command as before. I'm going to use size equal to 3. It's arbitrary choice. And you can say scale underscore shape underscore manual and specify the values of the shapes that you want, okay? A lot of these options, you can go to docs.ggplot2.org, okay? And you can go to geometry point, and it will kind of mention some of these different options that you can play around with, okay? And you can change kind of the scale, the scales here to different things as well, right? The scale shape and the scale size, these are all listed in the ggplot documentation. Okay, so plotting this, this is still, it's really hard to pick anything out here, right? This is not an ideal display, but you know, you might have better luck changing the plot characteristic. Okay, I think our eyes are better at detecting differences in color for these things, and you know, maybe the shape of the dot being plotted. The actual dot being plotted, our eyes are probably not great at that if you've got, I would say, more than 2 categories being plotted. But if you're plotting something like sex, okay, where you got probably just 2 categories to worry about, maybe third if people didn't want to just declare, you know, don't identify. You know, you might be able to have 2 different dots, okay, and it might not reduce the clarity of the graph. But here we've got, you know, 5 different types of cut, and you know, clearly it's very difficult to see what's going on here. Okay, I'll post all of this code up on CCLE as well, so you can kind of take a look at this. Okay. Let's see. Okay, so perhaps we want to do the size of the. So rather than the shape, we'll say the size of the dot is mapped to cut. Oh, and I should get rid of the. Of course, if I set the size of the geometry point here. Okay, and so this ruins everything as well. Let's see, alpha equal to 0.1. Yeah, this is not the ideal data set that we should be working with here. Let me find another data set. Let's well, 2:45. This is probably not the best time to pick a new data set. With this graph, you can see. I don't know if you guys can see this, but if it's the ideal cut, the dot shows up the largest, and if it's a fair cut, the dot shows up the smallest. And so we can kind of see, you know, a few things where the larger dots tend to show up top, but we still kind of get a variety. You know, up top, the cuts are more likely to be ideal, but right around here, we're still getting just good cuts. And then down here, we also have different sized, you know, different quality of cut. Okay, and then you can start combining these things, right? So we can do color is equal to the color of the diamond. So let's change this, and maybe I want the custom scale color Brewer. And this is, I don't want the, see here I'm trying to plot both cut and color. So, you know, I'm trying to display more than one, you know, four variables, right? Carat and price, and so we see this overall trend that larger diamonds will command higher prices. And then we're looking to see if there's any trend in the color. Overall, the general trend is that the better colored diamonds, the lighter colored ones, tend to be up top, but maybe that trend is a little bit lost. And if we're looking at the size of this dot being plotted as far as cut goes, it's a little bit harder to detect any kind of pattern. And so perhaps cut does not play a huge role in the price of the diamond, especially for things less than 1 carat in size. Maybe it does. And you can try flipping around these attributes to see if it affects the kind of the interpretation. Like, can you still pick out some of these patterns? So now I'm going to map cut to the color and color to the size of the data point. And so as far as color goes, I think we still see that general pattern where the tiny dots show up top and the larger dots show up at the bottom, meaning the best colored diamonds command the highest price, where the poorest colored diamonds command the lowest price. And as far as cut goes, it's still hard to see any kind of pattern based on the color of these things. Okay, so yeah.
You alluded to adding like a fifth variable after like 5, it becomes like it loses like elegance and simplicity. I'm assuming the fifth variable at this point is like shape.
Yeah, probably the shape, or
after that it just gets kind of
yeah, I mean, really, yeah. And so, and shape, we've already saw the problems with trying to map, variables with more than, and shape really only works for discrete variables, right? So if you had kind of this other continuous variable, you certainly can't do it to shape. You can do a continuous variable to color, as long as it makes sense in this regard. But yeah, as far as scatter plots go, again, go back to the beginning questions, which is, what is the point I'm trying to communicate with this graph, and what's the simplest way I can do this? And maybe it requires you creating multiple graphs, and that might be a better solution than trying to fit 5 variables into one convoluted graph that's hard to interpret. So, so creating good graphics is always kind of this exploration / communication problem, and so you want to try these things out and see what you can get. And Ggplot makes it very easy. You just kind of map the aesthetics to the variables you want and do GM point, and that's scatter plots in Ggplot. Okay, we'll see you guys in a couple.